Okay, so we're going to talk about how to solve trig equations using linear methods. So this is a whole series on different ways to solve trig equations. Okay, so first of all, what are linear methods? So this is like your basic algebra 101 solve for x, right? So the whole idea, the thing that matters here is that you remember the philosophy. The philosophy is that we want to isolate x, right? That's really what we're trying to do. So to do that, first we subtract the 4 to get 2x equals 4, and then I divide both sides by 2, and then I get to my solution x equals 2. Okay, so that philosophy kind of carries forward when we're working with a trig equation. Now, it is a little bit different. So what we want to do is we want to solve for theta, but right now we've got tangent of theta. So our first goal will be to actually to isolate this. So you're going to go through the same steps that you would have, as if this were an x. So treat tangent of theta as if it were an x. So what would we do in that case? So of course I'd start by adding my square root of 3, and then I could divide both sides by 3. Okay, and now here's the little plot twist. So now I have to figure out what is theta in this case. And so you can, of course, use the unit circle now to help you figure out from 0 to 360 degrees what values are going to give you, what values of theta are going to give you square root of 3 over 3. So remember that to do this, we're going to be looking at the y coordinate over the x coordinate. So when I reference my unit circle, so let me pull it up. Now, if your trig chops aren't quite up to snuff when it comes to working with tangent, so like one way you can kind of figure this out is you can look at the two coordinates that have a square root of 3 in them, and then you can just do the math, right? So I take the y coordinate divided by the x coordinate. So in this case, this will be square root of 3 over 2 divided by 1/2, dividing by 1/2. I just need to save space here. This is equivalent to multiplying by 2 over 1. So this just equals the square root of 3. And then if I compare that to 1 over 2, and I'm just going to multiply by the reciprocal, 2 over the square root of 3. So this gives me 1 over the square root of 3. And then if I rationalize, that becomes the square root of 3 over 3. So this, this is the coordinate pair that gets me that answer that I'm looking for, or gets me one of the answers that I'm looking for. So that's 30 degrees, because remember, we're in degrees. Now, we're talking about the unit circle here, so from 0 to 360 degrees. Are there any other coordinate pairs that would result in this? Yes, right? So if I come over to here, this negative divided by the negative, i.e. 210 degrees, that should also get me to square root of 3 over 3, because the negatives will cancel out. So 30 degrees and 210 degrees, those are, so let's see, I'll get rid of this. So my theta is equal to 30 degrees and 210 degrees. Okay, so that was over the interval from 0 to 360 degrees. Now, what if I made a tweak to this and I said for all solutions? So what is this getting at? Well, let's think back. So let's take just a quick field trip to remind ourselves about the good old graph of tangent. Okay, so using the unit circle, this is actually a very helpful guide to help us figure out the pattern of how solutions look. Okay, so remember, we talked about 30 degrees and 210 degrees were our first solutions, but now I can actually use the unit circle and allow myself to keep going around. So here's what I mean. Let's say I start here at 0 and I go one full rotation, so that's going to bring me to 360 degrees. Now, I can continue this, and if I come up to here, this is no longer 30 degrees, this would become 360 degrees plus 30 degrees. And so that would be 390 degrees. So that would be the next solution. And then I could continue here, and then again, this wouldn't be 210. I would take 360 plus 210 degrees. Now, and then I could just continue that, right? So I could continue to go around the circle as many times as I want, and then I could just multiply iterations of 360. Now we can be a little bit more concise than having these two separate solutions. There's one other thing I want to point out to you. So let me get rid of all this for a moment. 30 and 310, what is the difference between these? These are 180 degrees apart. So actually, so starting at 30, with each 180 degree iteration, so if I go around 180 degrees, that gets me to 10. With each iteration of 180 degrees, that gets me to another solution. So if I go another 180 from this spot, that gets me back here, right? And so then that would actually get me to two iterations of 180. So this would get me to that 390 that we just found. And then if I go another 180 degrees, that would bring me up to 670, and then I could continue going around the circle. So this actually perfectly summarizes up the possible solutions. So for all solutions, this would be 30 degrees plus 180 degrees times n, where n can be any integer, positive or negative, because I could also go in the negative direction around the unit circle, and that would also be totally fine. So that is how you would get all solutions. So you have to kind of figure out these little formulas, I guess. But it's not too bad. I mean, if you are 180 degrees separation on the unit circle, then you can just kind of easily figure out one of these little formulas. Okay, so just to wrap this up, this is a very short video. I have one more for you. I would recommend that you pause the video here, you give this a try, see if you can do it, and then hit play when you're ready. Okay, so let's see. I'm going to start by subtracting that 3. So if I subtract the 3 from both sides, this becomes 2 sine x equals 1. And then if I divide both sides by 2, I get sine x equals 1/2. So now using my unit circle, where does sine of x equal 1/2? Well, okay, so keep in mind, you're not using an inverse function here. You might be thinking, oh, you know, what if I took inverse sine or whatever, would that change? Remember, we're being told that we need to find all solutions over this interval, so that's the entire unit circle. So I'm looking for where I have the 1/2 for my y. So that would be here and here, right? And so obviously we're in radians, so that's going to be 5 pi over 6 and pi over 6. So those would be my two solutions, pi over 6 and 5 pi over 6. Okay, so like I said, short and sweet video, so just to kind of get you the basics. So I have more videos in this series, so I'll see you guys in the next video.